that incorporates the new piece of DNA into the mouse cell.
And we put an enormous voltage jump on this, and in the process what happens is that the little holes are opened up in the cells, and the DNA slips into the cells and then goes into the nucleus and then participates in making the DNA of the mouse.
In this way, he can change the mouse embryo when it's just a small cluster of cells, and then observes how the new DNA affects the way the animal forms.
Will it affect the growth of cells? Will it affect making particular bones? Or will it affect making the muscle or the tendons in that limb? Or will it affect all of those?
This is one of the best ways to study what specific genes actually do. He sees how the new DNA affects the embryo, how it changes the adult mouse, even how it alters the mouse's offspring as the change is passed through generations. This mouse has had a gene switched off so it cannot move its face muscles. It cannot blink. Now that might sound cruel, but Mario Capecchi does this because there are children who are born without the ability to move their face muscles, and his research is designed to look for a cure.
The amount of knowledge that we get by studying the function of a gene in a living organism is enormous. I mean, most of our previous knowledge, we were off completely as to what a gene is doing in a living organism. And the only way to find out is actually to alter it and see what happens. Genetically, mice and humans are almost identically. That is, the 99.9% of all the genes in a mouse and a human are going to be the same. So whatever actually we learn in a mouse is going to be directly applicable to humans.
The technology that he's using to do this could have another application. Just as Dolly the sheep has opened the door to human cloning, Mario's mouse shows the way towards human enhancement. But if the technology were to be used in this way, would science have crossed the threshold of what's acceptable? Most agree that Mario's work should be used to cure illness, but many question trying to use it to make us more intelligent. However, Watson doesn't see a clear distinction between the two.
By saying healthy, your brain is also healthy, and if you really are stupid, I would call that a disease. Stupidity is, a disease of the brain. The lower 10% who really have difficulty, even in elementary school. What's the cause of it? A lot of people would like to say, well, it was, poverty and things like that, but it probably isn't. And so I'd like to get rid of, help that lower 10%.
Does Watson draw the line anywhere? How about more cosmetic changes, making people better looking?
Everyone's saying it would be terrible if we made all girls pretty. Okay? Well, I think it would be great.
And it's those kind of comments that make some people think that Watson's judgment has gone off the rails. They argue it would be crazy to make such changes to our DNA, lumbering generations to come with our current cosmetic preferences. But before discounting his views, one should hear what else Capecchi is planning. He's turned his attention to chromosomes. Our DNA is wrapped up into 23 different sets, which carry our genetic traits from one generation to the next. Capecchi doesn't want to tamper with any of these. He's thinking about making an extra artificial chromosome. It would carry a bundle of genetic improvements, which he could switch on and off, just like he does in mice. The artificial chromosome could even be upgraded, like computer software, before being passed on to the next generation. Any alteration comes with a kind of money-back guarantee.
It does in the sense that you're not stuck with it. I mean, you're not changing the genome forever. You can change it, and if you're pleased with the results, you can keep it. If you don't like it, then you get rid of it and go back to the previous situation. And this is very important because what we may think is brilliant today, 20 years from now may seem pretty stupid. And whatever they think about in 20 years from now will be stupid 20 years hence. So it's very important to make the system reversible. And I think that's technically possible.
What's wrong with it? You say, well, give them an unfair advantage. But some people now are born with, much better abilities than others. And we don't say they shouldn't be born.
It's graduation day at Oxford University. a university famous throughout the world for academic excellence. But it's a place where only the most intelligent are allowed in. For Watson, these kids were just lucky in the genetic lottery. But why can't those with bad genetic luck be allowed to improve themselves or their children?
It seems unfair that some people don't have the same opportunity.
Watson thinks it's inevitable that this inequality will be overturned.
Once you have a way which will improve our children, no one could stop it. If you had the technology, you'd be stupid not to use it, because someone else will. Those parents who enhance their children, then their children are going to be the ones that dominate the world.
Good to see you, man. I can see anything.
A lot of people dislike genetics because we're talking about inequality, and people who say who have cystic fibrosis, they don't want to be declared unequal. And so they can say we're different, but basically it doesn't matter. Deep down when you get close, it does matter.
Cystic fibrosis is just one of 5,000 genetic disorders that have so far been identified. One in 25 people carry the gene and therefore have a chance that their children could suffer from it. The cause of genetic disease is one of the many things that 50 years ago Watson helped explain when he made his big discovery. When he saw the beautiful spiraling double helix shape of DNA, he saw how DNA copied itself, how genetic instructions could be passed on through generations. But he also saw that his copying process could make mistakes. These mistakes could occasionally be beneficial, and that would allow organisms to improve and evolve. But the majority of the copying mistakes were detrimental, the cause of genetic disease. That's the theory, but today Watson is more concerned with the practical. The final place Watson wanted to take us on his tour of the future looked like just another lab.
In these two sections of the lab, it's mainly movement disorders and neurodegeneration. That's where a lot of patients in clinics above the age of 50 start developing tremors. So we have a clinical senior scientist.
This is Kay Davis, and this is her lab in Oxford, a place where they look for cures for a variety of different genetic diseases.
Design a treatment.
She has a team of scientists and all the latest equipment.
So all of this is genetic analysis by now.
It's an expensive operation, and it's supported by the fundraising of Jim Watson.
But it would also fund things like the PCR machines, which amplify the DNA several millions of times. So we can take a small sample and then analyze it, because we can copy it lots of times and then get enough of it to look at the details.
For Watson, labs like these are the culmination of a lifetime's work.
What we're talking about is what's real diseases, really serious diseases that we have an opportunity to do something about.
Serious diseases no child should be born with. There's no purpose there. You know, it's all Darwinian. There's been, selection of those the fit, and then constant generation of new variability. That's it. There's always new variability. If there had been no new variability, there'd be no evolution. But the price of this variability is some people are born with variability which is no good. What I call genetic injustice. And what the world of human genetics is trying to do is to reduce the level of injustice. It's not out to create the perfect human or anything like that. It just sees this form of, just like any form of injustice, is corrupting if you accept it. So we can't accept it.
And that's